Field verification and diagnostic testing. There are three references that we'll be using for this training. We'll start with the 2019 Building Energy Efficiency Standards, which can be found at that link or downloaded from the file section of the training platform. We also have the 2019 Residential Compliance Manual, also found at that link or downloaded from the training website. And then we have the residential reference appendices, specifically section RA3. And again, there's the link to get it off the Energy Commission's website, or you can just download it from the file section. The Building Energy Efficiency Standards, or BEES, requires that certain aspects of the building be field verified and or diagnostically tested by a HERS rater. In this section, we will cover what those items are and how you can determine when or if they are required. These are commonly referred to as HERS measures. The overall training goal is for you to be able to identify the different measures and when they are required. So we've broken this up into three different sections. So the first one is, why do we need HERS raters? The second one is, what are the HERS measures? And then the third one is how to determine what HERS measures are required. Let's start with, why do we need HERS raters? The local building departments that are tasked with performing the inspections on homes are not equipped to handle these types of inspections. HERS raters perform these inspections on behalf of the local building department. So what we have, the local building department is essentially a health and safety inspection arm of the city. So they want to make sure that the home is going to be safe for an occupant to be in and not create any kind of hazardous conditions to the occupant's health. HERS raters, they work in the energy section or sector. They have the equipment, they have blower doors and duct blasters, and know what to look for from an energy related side of things versus just health and safety. So the HERS rater industry was looked upon to come in and perform these inspections on behalf of the local building department, and so that local building department relies on them to perform complete and accurate inspections so that the home is not only safe and healthy for the occupant, it also is energy efficient. So now let's talk about HERS measures. There are a total of 18 HERS forms, which is the CF3R, or we commonly just refer to them as 3Rs, with many having several different variations to account for the multiple measures documented on each. So these are the ones where you've seen it's, for example, the MEC 20A, or I'm sorry, yeah, the MEC 20A, the MEC 20B, MEC 20C, and you have it for new construction or newly installed systems, altered systems, smoke test, on and on. So there's a lot more than just 18 HERS forms, but there's 18 base HERS forms, and so we're going to take a look at those here. Now these CF3Rs and also their corresponding CF2Rs, which the contractor deals with, they fall into one of three categories. So it's either going to be envelope, mechanical, or plumbing, and they're designated by ENV, MCH, and PLB, but oftentimes we'll just refer to them as envelope, mech, or plumbing. So you'll have, or just the ENV 20 is the blower door form. MEC 20 is the duct blast form. PLB 21 is plumbing distribution. So that's usually how we refer to them and what they relate to. The envelope forms include those items that make up the shell of the home. So this is the outside, walls, ceiling, floors, windows, doors, anything that's in that shell of the home. If the HERS measure has to deal with that, it's going to be handled on the envelope forms. The mechanical forms cover the mechanical systems in the dwelling. So this is going to be your space conditioning systems as well as the ventilation systems. And then the plumbing forms is going to be, it's going to cover your domestic hot water systems that are in the dwelling. So these are going to be your water heating equipment as well as your distribution systems. And this can be either single dwelling, or it can be for multifamily. You'll have these central systems where it'll be a single water heater that serves multiple dwelling units. Now that we've talked about the core form types, the ENV, the MEC, and the PLBs. Let's look at the individual forms themselves. So let's start with infiltration reduction. This is going to be the ENV20, and this is more commonly referred to as a blower door. And so what this does is it measures the amount of air that passes through the building envelope at a pressure difference of 50 pascals. A leaky envelope leads to higher heating and cooling cost. So the more that the air, the unconditioned air from outside can move in and out of the building, the more you're going to have to heat and cool that air, because it's going to be in the wintertime, you're going to have cool air coming in, or more likely the warm air is going to be getting out. And then in the summertime, it's going to be the exact opposite. It's going to be hot outside, and that hot air is going to get in, so that AC is going to have to run more. So we want a nice tight shell to minimize those additional costs associated with envelope leakage. Quality insulation installation is going to be covered on the ENV21 and ENV22. This is more commonly referred to as QII, which is just the acronym for quality insulation installation. So QII, even though it says quality insulation installation, does not only look at the insulation, but it also has air sealing measures that are taken to reduce airflow through the envelope. So it kind of ties hand in hand with the infiltration reduction credit, although they are not a prerequisite for each other. They just know that if you're going to do QII and you're going to build a nice tight shell, that's going to help the insulation work better as well, because insulation works best in a sealed environment. Insulation will allow unconditioned air to move freely through it. It only works to slow the conduction of heat. So we go back to our basics of building science, and we have different types of heat movement. Conduction is where insulation comes into play. It slows the movement of heat through those solid surfaces, but it's full of pockets of air. And so if you have a leaky cavity where that insulation is installed, and you have warm or cold air just moving through to get from outside to inside, the insulation is not going to work. So we need to have a nice sealed environment for that properly installed insulation to work at its most efficient values. Duct leakage is covered on the MEC 20. And so duct leakage consists of ducts that are properly installed and that have very little leakage of the heated or cooled air. Now there are different testing parameters based on the type of installation, whether it's a new system or an altered system. And then also included on the MEC 20 are the following. You have low leakage ducts in conditioned space and low leakage air handler unit. So all of these, I believe there are 5 different variants of the MEC 20, but they all deal with duct leakage. So you have your air moves through the HVAC system, it gets heated or cooled, and then it runs through the duct system, which is the distribution system, and it goes to various parts of the house. Well, if those are full of holes and they are under pressure, whether it's the supply ducts are under pressure, the return ducts under a negative pressure, well, you don't want to have that heated and cooled air just flowing out into the attic. You want it to go where it needs to go, to the supply register in a specific room. So we really want to keep these tight. There are several different parameters, as we mentioned, new versus altered versus low leakage ducts versus low leakage air handler. So you really have to pay attention to the CF1R documents to ensure that you're testing to those right and correct parameters. Duct location is on the MEC 21. And so ducts that are typically installed in an attic will not be as efficient as those installed in conditioned space. So credit is available for installing ducts mostly or completely within conditioned space. So ductwork, as I mentioned, carries heated or cooled air, and it's usually going to be in an attic space, and the attic is going to be much warmer or cooler than the interior of the home or than the air itself. And so you're going to get heat transfer through that duct itself. So the duct is going to be insulated. And so if you can put a duct into a location where it is the temperature is more close, if there's not as much of a delta T in temperature, then you're not going to have as much heat transfer, and so it's going to be more efficient. So duct location deals specifically with locating ducts in spaces that are better suited for minimizing that heat transfer. Fan efficacy is going to be on the MEC 22. Air distribution fans that have to pull air through undersized return ducts have to work much harder than those paired with properly sized ducts. Measuring the fan watt draw, or FDW, ensures that the ducts are properly sized. So again, this deals with the duct system, and you'll have return ducts. This is where the air gets drawn from the house into the HVAC equipment, where it is then heated or cooled and then distributed out through the supply ducts. So oftentimes these return ducts are either going to be sized too small for the amount of air that they need to move, or they're going to be too long, or they've got too many bends in them. Whatever it is, it's going to create high static pressures, which indicates that the fan's going to have to work really hard to suck that air through. So you can imagine, picture a straw. You have a really skinny straw versus a fat straw. It's much easier to suck a liquid up through a fat straw than it is a skinny straw. And so this works under that same principle. We want to make sure those ducts are properly sized so that the fan operates within its efficiency range and is not working harder than it needs to. Airflow is on the MEC 23. And airflow does go kind of hand in hand with the fan efficacy or fan watt draw test. So air distribution systems need to be designed to allow the correct amount of air to pass over the evaporative coil for maximum efficiency. This includes both the supply and the return ducts. So this diagnostic test measures the return airflow and compares that to a default value based on the size of the system. So not only do we measure the fan watt draw to see how hard the fan is working, we also measure the airflow to ensure that that return duct at the size that it is and with the fan working as hard as it is moving enough air across the evaporative coil so that the cooling system can achieve its maximum efficiency. If we don't have enough air moving across it, it's going to cycle on and off more, and it's not going to be efficient like we need it to be. So we're going to measure the airflow at the return duct, and airflow is not restricted simply by the return duct, but it's also by the supply duct. So we want to make sure everything's balanced and is working within typical industry standards. Refrigerant charge is going to be the MEC 25. So air conditioning systems utilize a refrigerant to provide cooling. This refrigerant must be added to the closed system in correct amounts to achieve maximum efficiency. This diagnostic test takes several measurements to determine if the system was charged properly. So when they add this refrigerant, that's called charging the system, and they can either overcharge or undercharge the system, which means they just either added too much refrigerant or they haven't added enough refrigerant. But this charge can also be affected by the metering device, which we'll get into that when we get into the actual refrigerant charge section, as well as the airflow across the coil. Depending on the coil design and where the ductwork is located, sometimes that can affect whether or not the system can achieve the proper charge within this. So we're going to be measuring that charge, taking some temperature measurements, as well as the airflow. Airflow goes along with this as well. If we don't have enough airflow across that coil, then it's not going to be able to be charged properly. So we're going to test the airflow as well. So as you can see, several of these kind of piggyback off of each other, but this one is really important for those areas where AC is used a lot. Rated systems is on the MEC 26. The efficiencies of all HVAC systems are documented either by the manufacturer or by a third-party organization. The code dictates the minimum allowed efficiencies, but better than minimum values can be claimed and must be verified. So this is where in the performance modeling, they'll claim a value that is better than the minimum allowed efficiency. And so your role as a HERS rater is to collect the information about this HVAC system, look that up in a database to verify that that equipment either is equal to or better than the values that were modeled on the CF1R. So this is strictly a visual inspection. You're just collecting make and model information and then looking up to ensure that the values are equal to or better than what was modeled. Mechanical ventilation is the MEC 27, and so specifically this is the whole house or IAQ, indoor air quality ventilation system. So the envelopes of homes are becoming tighter. This can trap contaminants within the home, creating unhealthy conditions. The code requires that a whole home mechanical ventilation system is installed, and this system must provide a specified amount of ventilation and must be verified. So as we mentioned in the envelope section for the blower door and the QII, a nice tight shell helps the home to be more efficient. But when you have a tight home, you're not getting the change of air inside the home, so you can trap those contaminants, whether it's off-gassing from materials that are in the home or moisture, whatever it is, you can create an unhealthy condition inside that home. So you need to have controlled ventilation within the home, and so that's what this is. There will be one or more systems installed inside the home that are going to move air from inside to outside and exchange that in various ways. And so this particular test, what we're going to do is we're going to measure those systems to ensure that the amount of air movement that is required is achieved. And so that value is going to be on the CF1Rs. And so you're just going to measure it, make sure that it's equal to or better than the value that's required. Return duct and filter grill design is going to be on the MEC 28. And so this is an optional alternative method to verifying the airflow and fan efficacy. So a few slides ago, you remember we were talking about airflow and fan efficacy and how we're going to measure how hard the fan is working and making sure that enough air is flowing across the evaporative coil, so we're reaching those efficiencies that we need. Well, this is an alternate to performing those tests. So the contractor can say, I'm going to take this option, and then as the HERS rater, you're not going to do airflow and fan efficacy testing. You're going to verify that the system is installed per the specifications that are listed, and we'll go through those when we get into that section itself a little bit later. But it specifies duct and filter sizes to ensure proper airflow and fan efficacy values. These sizes are usually much larger than what would be required with a proper design. So you're not going to see this very often, just simply because of that fact that they're going to have to install much larger duct than what they would if they just did the proper design calculations. So we're not going to see it very often, but it is an option that is available to the contractor. Duct design and buried ducts is going to be on the MEC 29. So duct systems that are designed to minimize the total length of installed duct will be more efficient. Ducts that are partially or fully buried in blown-in insulation will benefit from higher effective R values. So again, let's go back to, duct systems are usually in an attic where it's a pretty harsh environment. There's a large delta T between the air temperature inside the duct and the attic itself. So if we can minimize the total length and diameter of the ducts that we need to deliver the air into the home, there's less surface area for heat transfer to occur. So it's going to be more efficient. In the same way, ducts, if we can improve the effective R value of that duct, because usually it's going to have, a 1 inch or maybe a little bit more of insulation on it. Well, if we can run it down low along the ceiling, and then we blow attic insulation and either fully cover it or partially cover it, we're going to increase the effective R value. So we're going to minimize the heat loss over all or part of that duct, again, making it more efficient. So any way that we can minimize that heat transfer through the duct wall, that's going to make for a more efficient system. So that's what we're seeing here with duct design and buried ducts. Ventilation cooling is the MEC 30. And so ventilation cooling, don't get it confused with the whole house ventilation system that we just talked about. That one is there strictly for health and safety reasons. It's not for energy savings, where the ventilation cooling is strictly there for cooling purposes. It's a potentially more efficient way to cool the interior of the home. So areas where cool evening and overnight temperatures can benefit from drawing in this air to help cool the interior of the home. These types of systems will use less energy when compared to refrigerant-based cooling systems. They will utilize the same fan and air distribution system as the HVAC system, and it will pressurize the home. So a ventilation cooling system is essentially you're going to have an additional return duct, and this is ducted to the outside. So it's going to draw in outdoor air into the HVAC system, The AC part of that system's not going to run. All you're going to do is turn the fan on. It's going to suck the air from outside that's nice and cool, bring it in to that through the distribution ducts and into the home. And then it's going to leak out either through relief ducts, or potentially you need to have the windows cracked open so that air can get outside. But what you're going to do is you're going to cool the interior of the home with that outside air. Whole house fans is going to be on the MEC 31, and these are going to be very similar to the cooling ventilation system, but it uses standalone equipment. So this does require the homeowner to open windows to allow cool outside air into the home, and this one depressurizes the home and pressurizes the attic. So we saw in the cooling ventilation system, it's going to pressurize the inside of the home, and the air is going to be pushed out through windows or relief ducts. Where this is exactly opposite. This fan is installed in the ceiling itself, and it's going to push air up into the attic. So you're going to open the windows around the outside of the home. It's going to, again, draw in the cool outdoor air. It's going to suck it into the house, and it's going to take the warm indoor air, and it's going to push it up into the attic. Now that warm indoor air is still likely going to be cooler than the attic itself. So not only are you cooling the interior of the home, you're also taking air that's cooler than the attic, pushing it into the attic, cooling off your attic. So it works in two ways to cool both the home and the attic itself. Local mechanical exhaust is the MEC 32. So we already talked about the whole home ventilation systems. So this kind of goes along with that, but this is local. So this is for areas that produce moisture and other contaminants. They need to have the ability to ventilate that to the outside. So exhaust fans will be installed in the kitchen, bathrooms, and laundry room, and these need to be designed with fans that are appropriately sized. So we, along with providing, just fresh air to the whole home itself, we want to make sure that we can take those source contaminants and get them directly to the outside, so that they're not just going to spill off into the regular house and then have the whole house ventilation system have to deal with them. If we can deal with them directly at the source, then that's just going to improve the overall indoor air quality for the entire home. So these are going to be your kitchens, your bathrooms, your laundry rooms, where you're producing moisture is the main point there that we're trying to get out. But kitchen, you're going to have oils and smoke and things of that nature possibly as well that we want to get vented to the outside. So for this test, you're going to be verifying that they're there and measuring them to make sure that they're moving the appropriate amount of air based on the design. Hot water distribution is going to be the PLB 21 and PLB 22. So PLB 21 is going to be for central distribution system. So you're going to have a single water heater, and it's going to serve multiple dwelling units. So we're going to see that in multifamily. And then we're going to have the PLB 22 is going to be specific to single dwelling system, so single distribution. So this is one water heater per one dwelling. Now this is going to be most common in single family residences, but you can also see this in multifamily where they've chosen to use a single water heater per dwelling unit versus a single water heater that serves multiple dwelling units. So distribution of hot water has the potential to suffer from large energy losses. There are various strategies that can be employed to reduce this energy waste, such as a compact design, pipe insulation, drain water heat recovery, parallel piping, and demand recirculation controls. So again, just like on the duct systems for the HVAC system, the more hot water lines that you have running, the longer they are, the less they're insulated, the more heat transfer that we're going to have. And it's going to be going from the hot water to the cooler air around it. So we're going to lose that. We pay money to heat the water at the water heater, and then as we distribute it, we're going to lose some of that heat energy, which just simply costs us money. So these various strategies are there to try and reduce the loss of that heat energy from the heated hot water. Now that we've looked at all of the HERS measures, let's talk about how we determine what HERS measures are required. So there are three ways in which a HERS measure can be triggered. It's either going to be a mandatory measure, a prescriptive measure, or a performance option. Now we've already talked about these in the Title 24 overview. And so we're going to now look at each of the HERS measures and look at where we can find whether or not they're required. There's several different documents that we'll be looking at, CF1Rs, CF2Rs, and so let's look at which of those documents we can find this information for each of the different HERS measures. So as I mentioned, there are several forms that the HERS measures will be documented on, and it may be on one or more of the following forms. So we have 3 CF1Rs. So the Perf 01 is the performance version. This is the one when they do performance modeling. Now, regardless of whether it's a mandatory, a prescriptive, or performance option, it's going to show up on this performance form for you to see. Now, even though it's a prescriptive option, it may still show up on the performance form simply because it's prescriptively required and the person didn't choose to take that measure away and suffer the penalty. So they just left it there, so it's still going to show up. So we're going to see that there. The other place that we're going to see it, and these are both prescriptive forms. So we have the NCB01, which is a newly constructed building. So this is, you're building a brand new house and you don't want to use the performance method, you're just going to go prescriptive. You're going to use that NCB01. And then we're going to have the ALT02. ALT02 is for HVAC alterations. And so anytime we alter that HVAC system, it's going to trigger one or more HERS measures for it. And so we'll see those on there. The other place that we will see whether or not the test is required is on the CF2R MEC 01. So this is kind of the overall, kind of the parent document on the installation side. It is the CF2R. And this is where the installing contractor may be allowed to claim some exemptions or claim some options. For example, that MEC 28 for duct sizing, they can claim that option to do that instead of the airflow and fan efficacy testing. And then at the same time, there is some exemptions for duct leakage testing. If it's an altered system and the ducts are sealed or insulated with asbestos, then they don't have to do a duct test on it, so they can claim that exemption there. So the Perf 01, NCB 01, or ALT 02 may say that duct test is required, but then when you go to that MEC 01, you can see that that exemption was claimed, and then a duct test is no longer required and you won't need to do one. So those are the main 4 forms that you're going to be looking at to see whether or not a HERS test is going to be required. The infiltration reduction measure or blower door for the ENV20, it is a performance option. So you're only going to find that on the CF1R Perf 01, and you're going to find that in the HERS feature summary. Now, in the actual blower door training, we're going to take a look at where you're going to find the target values, because you're going to need to know what your test value needs to be. And so we'll cover that. We'll show you where that's found on this CF1R Perf 01, but it's overall going to be found in the HERS feature summary, like we showed in the Title 24 overview. Quality insulation installation, or QII, is a prescriptive measure. So you're going to find that on either the CF1R Perf 01 in the HERS feature summary, or on the CF1R NCB 01 in the HERS verification summary. Duct leakage, which is the MEC 20, is a mandatory measure. So you're going to find that on all of the documents. So on the CF1R Perf 01, we're going to find it in the HERS feature summary. On the NCB 01, it's going to be in the HERS verification summary. On the ALT 02, it's going to be under required documentation. And then on the CF2R MEC 01, it's going to be in the HERS verification requirements for duct systems. And the MEC 01 has 4 different variants. It has an A, B, C, and D. And so this HERS verification requirements is going to be either section M, J, L, or O, depending on which variant of the MEC 01 is being used for that particular project. Now, because duct leakage is a mandatory measure, it is going to be required when any of the following conditions are met. An entirely new or complete replacement duct system is installed, and this can be either on a brand new home or an existing home. If an existing duct system is altered, if an air handler, outdoor condensing unit of a split system air conditioner, or heat pump is installed or replaced, a cooling or heating coil is installed or replaced, or more than 40 feet of new or replacement ducts are installed in unconditioned space. So any of those will trigger the requirement for duct leakage testing. And again, you're going to see it on one of those forms that we described on the previous page. Now, low leakage ducts is also on that. It's part of the duct leakage measure. It's on the MEC 20. Low leakage ducts in conditioned space and low leakage air handling unit are both performance options. So you're only going to find those on the CF1R Perf 01 in the HERS feature summary. Duct location for the MEC 21 is a performance option. So again, we're going to see that on the Perf 01 for the HERS feature summary. But we're also going to see it on the CF2R MEC 01 in the HERS verification requirements for duct systems. This is only going to be on a single variant, and so you're going to find that in section M. Fan efficacy for the MEC 22 is a mandatory measure. So again, we're going to see it on all four sets of the forms, Perf 01 in the HERS feature summary, NCB 01 on the HERS verification summary, Alto 2 in the required documentation section, and then on the CF2R MEC 01 in the HERS verification requirements for duct systems. Again, this is available for all four variants of the MEC 01, so it's either going to be section M, J, L, or O. Now this does apply to entirely new or complete replacement duct systems. It does not apply to altered systems. And the systems can be modeled with better than default values using the performance method. So if the project has a Perf 01, you're going to want to look at that. And again, in the section where we talk about airflow and fan efficacy, we're going to have a screenshot of the HERS section on the CF1R where it's going to give you that target. So there are several default targets which we'll cover in that section, but they could possibly model it with a better value than the default. So you'll want to make sure that you check that CF1R Perf 01 to ensure that they either use the default or a value that was better. Airflow on the MEC 23 is also a mandatory measure. Again, it's found on either the HERS feature summary, the HERS verification summary, under required documentation, or on the MEC 01 in sections M, J, L, or O. It also applies only to entirely new or complete replacement duct systems. It does not apply to altered duct systems, and systems can be modeled with better than default values using the performance method. So again, in that section, we're going to cover what the defaults are, as well as where you can find those better values if they were modeled on the Perf 01. Refrigerant charge is a prescriptive measure. So if it is required, it'll show up on the Perf 01, on the HERS feature summary, on the NCB 01 or the HERS verification summary, on the Alto 2 under required documentation, or on the MEC 01 in either section N, K, M, or P, again depending on which variant of that MEC 01 is displayed. Now it does only apply to newly installed or altered cooling systems in climate zones 2 and 8 through 15. So if your project is modeled and it's in climate zone 3, then refrigerant charge is not going to be required, and it's not going to show up on any of these forms unless on the performance side they can select it as a performance option. So even though it's not prescriptively required, they can model it as a performance option, and then it will show up on that PRF 01. So these newly installed or altered systems, a system is going to be considered altered when a refrigerant containing component is installed or replaced. So if that component has refrigerant going through it, it's going to be considered a refrigerant containing component. They're going to have to draw down and remove all the refrigerant out of that system to replace it. That's going to be considered an altered cooling system. And then if you're in climate zones 2 and 8 through 15, refrigerant charge is going to be prescriptively required. Rated systems on the MEC 26 is a performance option. So we're going to only see that on the Perf 01 in the HERS feature summary, as well as on the MEC 01 under the HERS verification requirements for space conditioning equipment. It's going to be either section N or P, depending on which variant is displayed again. So this one, there are default values, and those are mandatory minimum default values. So when they do this, they take this performance option, they have to model values that are greater than the default, and they can do it for either SEER or EAR, or both. So what you'll need to do, and we'll cover this in the rated system section, is we're going to show you where you're going to find these modeled values, so you know what those targets are, so you have that for comparison when you do your visual verification. Mechanical ventilation on the MEC 27 is a mandatory measure. You're going to find that on the CF1R Perf 01 in the HERS feature summary, or the NCB 01 in the HERS verification summary. And so it applies as a mandatory measure to all new homes and additions greater than 1,000 square feet. And these must comply with the requirements of ASHRAE 62.2. So they're going to require a indoor whole house mechanical ventilation system. Return duct and filter grill design on the MEC 28 is also a mandatory measure, just like the airflow and fan efficacy were. As you remember, we talked about this is an alternative method for compliance for the fan efficacy and airflow requirements. So they both are mandatory measures, but you're going to do one or the other. Now we're going to find this, as I mentioned, some things, this is because it's an option. You select this option on the CF2R MEC 01 in the HERS verification requirements section for duct systems. So when that option is selected, it's going to be displayed as requiring the MEC 28 in either section M, J, L, or O, depending on which variant of the MEC 01 is displayed. Duct design and buried ducts on the MEC 29 and ventilation cooling on the MEC 30. These are both performance options. They're going to be on the CF1R Perf 01 in the HERS feature summary, and then you're also going to find it on the CF2R MEC 01 in the HERS verification requirements for duct systems in either section M or O. Whole house fan on the MEC 31 is a prescriptive measure. So we're going to see that on either the Perf 01 in the HERS feature summary or on the NCB 01 in section L. And so whole house fans are prescriptively required for new construction in climate zones 8 through 14. So this would be a newly constructed home in one of these climate zones. A whole house fan is going to be required, and so you're going to find it in one of those two locations. Local mechanical exhaust fans on the MEC 32 is a mandatory measure, and so you're going to find that on the Perf 01 in the HERS feature summary or the NCB 01 in the HERS verification summary. And these are required on all new homes with local ventilation requirements for kitchen, bath, laundry, etc. Hot water distribution, which is going to be either multifamily or single family. These are both performance options, and so you're going to find them on the CF1R Perf 01 in the HERS feature summary. As always, if you have any additional questions, don't hesitate to give us a call, send us an email, or message us through the training software.